Good day and welcome to Properties of Radical Functions, Part 1. What we're going to look at is radical functions, and what we're talking about there, and we're going to use the following approach, but we're talking about functions that have a square root or radical. But what we're going to do is we're going to take a look at some original function, we'll call it f of x, and then we're going to stuff it under the square root. So we're basically going to take a function that we might be very familiar with and then turn it into a radical function and examine what effect that has. In other words, it's kind of like these are the original points. So if you think of it in a table of values, we might have a bunch of points here. And what we're now going to do is take all those same points and take the y values, because after all, f of x here is like saying the y parts of your points, and we're going to square root them. So, for example, we might have a point like, let's say at -2, the y value is 0. So now at -2, we're going to square root that 0, and guess what? Actually, that point is not going to move. It's the same location. Maybe we have a new point that's at, I don't know, x value is 3, and maybe the y value is 4. Where would that point be now? Well, we would just take the y value and square root it. Okay? And so it would now be at the location of 3 and 2. So that's what we're talking about. We're talking about just taking these y values over here and square rooting them. Because that's what this is telling us to do. We square root the entire function value, which is like square rooting the y's. The x's stay the same. So that's kind of the goal here. But before we blast away at that, there's a few key things we should look at, like, and one of them we just ran into. If you square root 0, it's not going to change. It's still going to equal 0. And there's another point that does that as well. If your original y value was 1 and then you square root it, it's still 1. So these are what we call invariant points. They don't move. Okay? They are in the exact location they were to begin with. Okay? The other thing that we have to do is when you square root, it has to be positive. Okay? So function values that have gone negative, or that started out as negative, we can't square root those. So they simply don't exist. So I think we're probably ready to start with our first example. So let's clear the screen here and have a little look at a function like this. Suppose our function was something nice and straightforward like a straight line, x minus 2. So that's the original, and what I'm going to do is I'm going to gather a whole bunch of points here in a table of values. Give myself a little something to work with until I get really confident that I know what I'm doing. So let's put in a bunch of x values here. Let's go as far as, say, 4. And the y values, well, we could get them from the function. So we plug in x as 0. 0 minus 2 would be -2. Then we plug in the 1, and we would get, looks like -1. Plug in the 2. 2 minus 2 is 0. Plug in the 3. 3 minus 2 is 1. Plug in the 4. 4 minus 2 is 2. So these are the original points. Now what we're going to do is have a little look at a new spin on this function where we're going to square root it. So we're actually just going to throw all this stuff under the square root sign. And now we're going to make a new table of values. Now, this is actually easier to do than it looks. All we're doing is taking these y values here, and we're going to square root them. So we're going to go x is 0, and we're going to try and figure out the square root of -2. We go, oh, you can't do that. So that doesn't exist. Empty set. Let's go to the next point. Square root of -1. Oh, can't do that. Doesn't exist. Okay. Now what about when I square root the 0 here? Okay, square root of 0, that's fine. That's going to be 0. Looks like an invariant point. And then the next one, very similar, I'm going to square root a 1, and I also get the same y value. And finally, the last point here, I'm going to square root the 2, which I can do. And for the sake of graphing, I'm just going to get a decimal approximation. So guess what? I have a whole bunch of points here, and I'm going to examine them and show you what's going on here. So let's see, maybe what we can do, you probably have all this in your notes, so I'm going to clear the screen and set up a little grid, and I'm going to do quite a magnification on there to show you what's going on. So let's draw a little bit of a grid here. Okay, something like that. And I think we can mark these off fairly far apart. So we really only want to do a magnified zoom kind of thing on what's going on with our little graph here. First of all, I'm going to draw the original. And if you look at your notes, you've got, it goes through 0. I guess I should have gone down a little further. It's going through 0 and -2. And then it's going through 2, 0. And so on. And we've just got a straight line. So let's go ahead and draw the original. See if I can do a good rendition of it here. Okay. A little bit off there. You know what? I'm going to try starting that again. So let's throw that guy out. Start a little bit lower here. Actually, I'm just going to start right next to it here. There we go. That's a little bit better. Okay, so there's the original. This is y equals f of x. Now, right over top, I'm going to use little x's to mark the new points where I've kind of square rooted the function. Well, interestingly, all these points here, they don't exist, and the reason they don't exist is because they have negative y values. So all these guys are now no longer even in the running. Our first point that's in the running is this guy here. Okay, so mark that with an X, and that's because it's an invariant point. It hasn't moved. And then another invariant point is the point 3 and up 1, which is roughly here. Okay, so that's also a point on my new graph. And then I have this point 4, and in the original it was supposed to go up to 2. I think I'm a little off here. But now it goes up to 1.4, so we're going to say it's roughly about here. Okay, so I've got 3 points here. I can see it's actually not going to be a straight graph anymore, but what is going on? Well, let me just show you what happens here. These guys in this little zone, we're talking between the 2 and the 3, these points all have y values that are less than 1. The y values of these points are between 0 and 1. So now what happens in this zone here? Well, let me show you by using one of the original points. If I take an original point of, say, 2.5, okay, and if I plug that into my function, I will get a y value of 0.5. Now, this is an old point, an original point. Where is that point now? So here's the new version of that. Well, the x is still 2.5, but what I got to do is get the square root of 0.5, which is approximately 0.7. Now, what you want to note here is that the original point was down here at 0.5, and now I'm a little bit higher. I'm maybe about here. Okay? In other words, whenever you have y values like this that are between 0 and 1, and you square root them, you're going to get bigger numbers. So in this entire zone, the y values are going to be above. You know, they're slightly higher than they used to be. So you're kind of getting something that looks like this. It's got a little bit of a bend to it, and it's higher than the original points were. Now that changes once we go beyond this little invariant point here. If you look at these guys here, and here's a good example of that, you'll see the original point was up here, okay? But when we square rooted it, it's below, okay? And that's going to happen with all these points where their original y values were greater than 1. The new y values, because we're square rooting them, they are less than that. So the graph actually does something kind of like this. Oops, it's hard to reach that point. Yeah, it kind of has this kind of a curve to it. And that is our new radical graph of the square root of f of x. Okay? All right, I can see that we're running a little bit to where I think I'm going to stop, and we're going to come back and talk a little bit more about these radical functions. So I'm going to stop there.